for any academic activities. So I wish to introduce our Associate Dean to you, ma'am. And similarly, I wish to introduce our speaker, Anshu Bharadwaj, to our Associate Dean. Ma'am, he is
Hello, madam.
Yes, ma'am. She is a very eminent speaker. When I was witnessed in several training programs where I attended for 21 days under summer and winter schools, ma'am. And at the same time, I would like to introduce our university head and member of Board of Management, Acharya Engineering Agriculture University, Professor V. Srinivas Rao, sir, to the speaker.
Madam, good afternoon, madam. Good afternoon. I know madam from several years. She recently also you arranged one lecture, and she's so dynamic in computer division. I know, and Dr. Rajendra Prasad sir, and also Dr. Sudeep ji. They are the key persons there in IISRI, and since then when we organized the training program and conference also, she attended. Madam, thank you for accepting our invitation from Acharya Engineering Agriculture University, madam. Thank you.
Please unmute, Ji. Okay.
Namaskar.
Yes.
Yeah, madam. Yeah, madam.
By this, I request our Associate Dean to conduct the proceedings.
Good afternoon, everyone.
Good afternoon, ma'am.
Now I extend a warm welcome to Honorable Vice Chancellor, Dr. Vishnuvardhan Reddy Garu, for this national webinar. In the same way, extend a warm welcome to our Pratap Kumar Reddy, our Dean, and our University Head Statistics and Computer Applications, Dr. V. Srinivas Rao Garu. I am really happy, madam. I again extend a warm welcome to the speaker, today's speaker, Dr. Anshu Bharadwaj Garu, who is a principal scientist and head of Division of Computer Applications in IISRI. Madam, I happen to be in IRI, but I could not make it to IISRI at that time, way back in 89 to 92. I thought of doing, but I could not do it because I'm a genetics student there. Because of some hurdles, I came as in-service candidate, so I could not make it to IISRI. Some courses I thought of, but I could not do it at that time. But really, I'm happy that you are here with our university students and staff today to deliver the lecture on scope of big data analytics in agriculture and other sectors, madam. I heard from Srinivas Rao that you have vast knowledge in, of course, in computer applications with respect to big data, data mining, artificial intelligence, which are the really necessary, the tools necessary for today's agriculture, actually. Now, in the morning also, I was reading one company startup who is doing this, artificial intelligence based spraying of herbicides and insecticides, where we can reduce the quantum of these insecticides or herbicides that are being used, which is again have multiple benefits actually in reducing the cost as well as the health and environmental hazards. In this way, I think this artificial intelligence and big data tools, they have very good application, I feel, madam, in this agriculture and allied sectors. The topic is highly relevant nowadays, and we have to be with these tools. Now we have these drones and all that for applying for herbicides. If these are combined with these tools like artificial intelligence and big data, where you can have very good idea where the pest is or where the disease is, so that we can manipulate accurately the spraying and other operations. Madam, I once again welcome you to this lecture, again to this webinar. I am really happy, madam, that you are sharing your knowledge for our students and faculty. And Srinivas Rao sir, I think this is very apt, sir. Your staff are organizing this kind of national webinars and doing great service to the students as well as staff of our university. Thank you, sir. Again, thank you. I take this opportunity to congratulate Lavanya Kumari, Head of Statistics and Computer Applications, SV Agricultural College, Tirupati, and their colleagues, Nafiz Umar and Ramanamurthy, for taking the lead in organizing this national webinar. I wish you all the best, and I think you can proceed now, Lavanya, with your program.
Thank you, ma'am.
I will be coming out of this program now. I think you can proceed now onwards. Sure. You take the responsibility of conducting the seminar. Sure. I have some other works. I won't be with the national, and I won't be able to follow also these things. That is why I am coming out of this. Okay, I am logging out, and you proceed.
Thank you, ma'am. Thank you very much, ma'am, for the nice words towards this webinar. And I profoundly thankful to today's speaker, Dr. Anshu Bharadwaj again, Principal Scientist, Division of Computer Applications, IASRI, for her kind acceptance to be a speaker of today's webinar. Further, for the information of dignitaries and participants, I take opportunity to tell what is the combination of participants so that our lecture can be planned accordingly. And as information pertaining to the registration, we have 462 registrations. Out of them, 35%, 163 are from faculty and 33% from MSc students and 17% from PhD and 12% from others. And it covers almost all 8 states overall India and 9 agricultural universities, both state agriculture and ICR institutions. By this, almost all the departments have been covered, including agriculture and computer applications and mathematics also from other universities. So this is the favor of information to the dignitaries and the participants. By this, I take another opportunity to welcome to the program our university head, Dr. V. Srinivas Rao Garu, Head Department of Statistics, Computer Applications, Agriculture College, Bapatla, and a member of Board of Management, Acharya Engineering Agriculture University, as a special invitee and request him to give a couple of sentences on today's topic, that is big data analytics in agriculture and allied sectors. I welcome you, sir.
Thank you, madam. Thank you. First of all, I would like to thank the today's speaker, Dr. Anshu Bharadwaj. Madam, I know you from several years, because I was also a participant of IASRI, several 21 days training programs, and I was the SAS nodal officer for Acharya Engineering Agriculture University. We have a lot of association with IASRI. And Dr. Rajendra Prasad ji and our head of the department, Dr. Sudeep, we are very, they are the real mentors to all of the staff members of Acharya Engineering Agriculture University. And I want to congratulate the dynamic head of the department of SV Agriculture College Statistics and Computer Applications, Dr. Lavanya Kumari madam. She is arranging series of webinars. Last year also she arranged 3, and this year again she started. And with the help of the 2 dynamic assistant professors, Dr. Sheikh Nafiz Umar and Dr. Ramanamurthy. Really, I want to congratulate all the faculty of SV Agriculture College Statistics Department. And comes to the today's topic, really it is the need of the hour. Earlier, the data means only the numbers. When we started our statistics with facet machines, later calculators, and Excel, like at that time, the data is a handful data, and even our CRD, RBD, LSD, or multivariate analysis used to analyze the data with the help of only the Excel or other statistical software. But now the meaning of data was changed. Now we are collecting the data, unstructured data also. So even the signals, nowadays the farmers are using and the scientists are using drones, and we are collecting huge amount of weather data. And to identify or to predict the predictive models, definitely the big data analytics is very much useful. And getting data nowadays is not a problem. We have the unstructured data, even the text mining is also there. And like several areas, the big data analytics are penetrated into anywhere and all the domains. That's why nowadays, if you see, in all the engineering graduates are also coming to the data analytics side only. Though they are from different streams like civil engineering or mechanical engineering or any branch, they are learning some Python or R programming or some other SAS programming like, and they are entering into the data analytics, that is the big data analytics. And really, it is very much needed. Earlier, we have data analysis, then data warehousing, then data mining and big data. Like we are growing like anything. The data is coming from different folds and different corners. And it is the duty of a statistician to draw the meaningful information from the data. So definitely the tools which are available and also the programs there in R programming or SAS program, definitely it will show the required information to the scientists or the needy people. So really, I once again appreciate the head of the Department of Statistics, SV Agriculture College, for arranging this kind of webinars to enhance the knowledge of especially the PG and PhD students and to know every scientist the scope of big data and the statistics. Really wonderful, madam. And on this occasion, I thank all the associate deans, especially Dr. R.P. Vasanthi, madam. She is encouraging our statistics faculty at SV Agriculture College and also our Honorable Vice Chancellor. All the time used to give more importance for the statistics. And also the Dean of Agriculture, Dr. A. Pratap Kumar Reddy Garu. I wholeheartedly thank all the university officers and also the faculty of Acharya Engineering Agriculture University for allowing us and encourage to organize such kind of webinars and training programs, workshops, madam. So with these few words, I thank once again Dr. Anshu Bharadwaj for accepting our request. And thank you, madam, Dr. Lavanya, madam, and all other faculty. Thank you, madam.
Thank you so much, sir, for your kind words regarding this topic and our department for the sake of encouragement. Without whom also, ma'am, we could not proceed further for any academic achievements. He is very cooperative and he is giving continuous guidance to us to put forth our department in all the activities. And now I take opportunity to request one of the faculty, Dr. Nafis Umar, to explore the efficiency of the today's speaker by reading her biodata. I request Nafis Umar.
Okay, madam. Thank you, madam. So first of all, I'm introduce myself. My name is Dr. Sheikh Nafis Umar, working as assistant professor, Department of Statistics and Computer Applications. So good afternoon to all. So it is my privilege to introduce our invited speakers to today's national webinar on the scope of big data analytics in agriculture and allied sectors. So Dr. Anshu Bharadwaj is the principal scientist at Division of Computer Applications, ISRI, New Delhi. She has PhD in computer science from School of Computer and System Sciences, Jawaharlal Nehru University, New Delhi, in the area of artificial intelligence and machine learning, and LLB from Dayanand Agro Vedic Postgraduate College, Dehradun in 1998. MSc in Statistics from same college, there is a Dayanand Agro Vedic Postgraduate College, Dehradun in 1994. And also, she has postgraduate diploma in computer applications in 1992. She has over 26 years of experience in the research, teaching, and training in the area of statistics, computer science, and information and communication technologies. Guided and have been guiding more than 12 MSc students, 10 PhD students as the chairperson and advisory committee member. She published more than 30 papers and 10 books, chapters, and more than 20 popular articles. She has developed more than 50 technical bulletins, manuals, and also 30 e-resources for the students and the use of various software systems. So her areas of interest include data mining, data analytics, spatial data analysis, GIS, machine learning, and deep learning, among others. So once again, thank you, madam, for accepting today's national webinar on the scope of big data analytics in agriculture and allied sectors. Okay, madam, thank you.
Thank you very much, sir. And now I request our today's speaker, Dr. Anshu Bharadwaj, to proceed further. And before that, I have an announcement here. Many from the side of participants, we have been receiving many requests for Zoom link. We have sent clearly the YouTube link also. It is live streaming, and those who have not linked with Zoom, they can view from YouTube link, which is already shared among all the participants. This is the announcement from the side of organizing, because only 100 are allowed for this paid Zoom link. Okay, by this I request once again, Madam, please proceed further. Thank you, ma'am.
Namaskar. And first of all, I would like to thank the entire college for inviting me for this and thinking that I would be able to do justice with this topic, which is very, very current and very, very important in this scenario. And I would like to thank Dr. Vasanti, the Associate Dean, Dr. Pratap Reddy, and Dr. Vishnuvardhan Reddy, the VC of the university. I would also like to thank in the starting Dr. Srinivas Rao. And as he said that we are very familiar with each other. Thank you very much. Thank you very much. And my special thanks are to Dr. Sheikh Nafis for introducing me. Although I am not such a big person, but I am trying to do certain things, some small learnings in this area, which I would like to share in this another 1 hour, 1.5 hours. So thank you very much. And I'm really honored to be here amongst everyone to present what I have learned till now in big data. So I would like to share my screen. Is it visible?
Yes, ma'am, it is visible.
Okay. So as we all know that this topic is very important and it is very relevant in the scenario that we are living in. So since it is an introduction, so I'll keep it very simple. I would like to let the people understand what big data is, because there has been a lot of hype about big data, its analytics and the scopes and how to go about it. But I would like to go a little slow and little simple so that we understand it in the first step, and then we can move ahead. So what are the things that I would be covering in these slides? Since we talk of introduction to big data analytics. So big data is one thing, and then we are moving to the analytics. So in these slides, I would be talking of the introduction and the data trends. Then there are certain challenges which come up with the big data. What are the technical approaches and the tools that we can use in big data? Then the other part is analytics, where what kind of analytics exactly is being done with the big data? The analytics life cycle, how does it go? If we start thinking of doing the analytics, how we have to move ahead? There is a methodology behind it, and another, the tools for the analytics. Then I would, if the time permits, I would go with the use cases. There is one use case for sentimental analysis, which we would be like, I would be trying to do with statistical software or the mining software, along with the big data tool, that is Hadoop. So since the time is not that much, so that I can ask you to install and go ahead with me hand in hand with the Hadoop environment, but I would like to show it here that how you can do it if you want. So what are we talking of? We are talking of data, this kind of data, that kind of data, everywhere. And as I had just heard from Dr. Srinivas that we were talking of data in terms of numbers when we were talking of it a few years back. But now everything has become a data. You go and you swipe a credit card, that's a data point that you have created. You just go to, you come to your office, you put your thumb impression on the Aadhaar biometric machine. It is a data point that you have created. So data has changed its type. It has evolved. It has become a variety. This is a picture which shows that what kind of data we are talking of. You have emails, how many emails we sent in a day or we received in a day. This is really mind-boggling numbers. Data consumed by household each day. In a normal household, even if you call a grocery shop and ask them to receive the data, what we do Paytm. That's a data point that we have created, and we are not aware of that. Then video uploaded on YouTube every minute. There are millions of videos which are getting uploaded on YouTube from everywhere. There are professional people, there are amateurs, there are freelancers, there are even the kids are doing this. So it is so much data is getting generated. Data per day processed by Google. We can understand that. Then tweets, total time spent on Facebook or each day, data sent or received by mobile internet users, ordered Amazon per second, or not only Amazon, on so many e-commerce sites. So these numbers are beyond our imagination, but they have been created, they are real. So what is big data? We had been talking of data since ages. We have been collecting data, storing it, even analyzing it in the traditional methods. Now, when we talk of big data here, these are also the numbers that I was just talking of. It is the massive sets of data. But earlier, we had the data which was in terms of numbers, or maybe that we had categorical data also, where we had different kinds of analytical tools which were going to analyze them. But now, since data is coming from everywhere and in every form, signals are there, emails are there, videos are there, audios are there. So what is this? They are unstructured data. So when we talk of the data in terms of structured, unstructured, semi-structured, they become our big data. They are in petabytes, exabytes. So typically, our database management systems or the relational database management systems, in which till now we used to store our data and then analyze them, are not able to handle that, because they are having their limitations, wherein all kind of data cannot be stored. So what we have to move ahead, go and find a new way of storing the data, new technologies. So this is where the big data storage systems came in. Now, since we have already talked that the data is coming from multiple sources in various kinds, transactions are there, social media is there, enterprise content is there, then the sensors. When we talk of big data, we should first talk of the Internet of Things, that is the IoTs, and the IoT devices are creating and generating data every moment. Then mobile devices, I should not talk about it, because even a 5-year-old child is also having a mobile and talking of and watching YouTube or anything in that. Okay. So when we talk of data versus big data, because till now I was telling that earlier we were talking of this kind of data, earlier we had this data. So now what? What is the difference between the data and the big data? Big data is nothing that you will see, it's a huge data. No. Why we call it a big data? It has certain characteristics. It has to has the approval of having certain basic parameters. So data versus big data, when we talk of, the big data is just the data which has more volume. As I said, there are n number of resources which have come up and which are generating data at a very high speed. And when I talk of high speed, that means it's a faster data generation. So speed or velocity. So it has more volume, it has more velocity, and then it is having many variety. You have a multimedia data, which is video, audio, you have Twitter data, social media, mobile devices, IoT devices, sensors, everywhere. So there is a variety which has come up, and this variety is difficult to be handled by the traditional database management systems. Now, this is facts and figures which has been given that the world's data volume is expected to be growing by 40% per year and 50 times by 2020, and that is an old study which was told. But when we talk of today, it has grown much beyond that. So data is coming from various human and machine activities. Even the equipments, the technologies, the new gadgets, they have started generating data. When we talk of any new technology, what we try to do, we try to define it. We try to define it. So here I would like to define this. The big data is large amount of data. You can see it. It's a large amount of data. Then it is collected passively from digital interactions. So it is not that you are going to the field, taking your notebook and writing it down. It is not like that. It is in addition to that. So there are equipments, gadgets, and machines which are generating data and collecting them passively from the digital interactions with great variety and a high rate of velocity. So when we talk of big data, the definition tells that it's a heterogeneous mass of digital data. Heterogeneous means you have different kinds of data coming in the same way. You can store your social media data. You can store your tweets. You can store your photographs, your videos in the similar storage where you are storing your big data. So it is not only that your data is is in numbers or is in words, it is going beyond that. So that is why we call that it is a heterogeneous mass of data, which is produced by the organizations, companies, individuals, professionals, everywhere. So it has a very, very large volume. Different forms means different shapes and sizes, very high speed. And then that is why they require different and specific kind of sophisticated computer storage and analysis tools. So till now, what we were doing collection of our data from the fields and some equipments, putting them in our RDBMS or DBMS, and taking them out and analyzing them using our traditional statistical method and some machines or some softwares which had come up quite long back. So those softwares were also not very sophisticated. We were trying to do it, and more of this, when Excel came, when Windows came and Microsoft Office came in 95, 96, people were very happy that, okay, fine, Excel is something which we can analyze our data. Then small packages came, SAS came, SPSS came, but they had a different look and feel at that point of time. But now, if we talk of those days, we cannot even analyze the normal data with that. They have also evolved. We have also evolved with the data, the kind of data we deal with, the data kind of analysis we are looking forward to, because the requirements have changed. So the next thing is that big data, it refers to the evolution of use of technologies. As I said, that the softwares also evolved over the period of time. The collection method evolved over the period of time. The data generation methods also evolved. So all these things evolved, and that is why we needed the storage systems or storage methods to be evolved. So then what it provides is the right user at the right time with the right information. If you are not getting these things from your data, whether it is big data or data, it is of no use. Then you are just collecting junk, putting it at one place, and you utilize it, rather than utilizing the resources, you are misusing them. Because when I have a lot of data and I need some information at some point of time, I am not able to get it, it is of no use to me. We all know the data is exponentially growing in everywhere, and we need it. It is not that we don't need it. We also do a lot of analysis. A small example I tell you, if we go to Amazon, we see a product which is of our use. I just look at the product, and what is the thing that I look at to whether to go and buy it or not? I will look for those 5 stars which are given on that, references, right? Feedbacks. So what is that? People are giving that, and we are also using that data to decide for decision points. So that is why it's a very small example, which everyone is doing. And I say, no, iski rating achhi nahi hai. It doesn't have a rating of 3 or 3 star or 4 star. So I will not go with that. What is it? This organization this company has collected a lot of data and it is giving it to you after, and so that you can analyze and take a decision. This is what data is for. So before moving any further, I would like to talk about a little of big data evaluation. How did it evolve? When people started talking of data as a big data, when this transition came, and how this term started getting used by the people. So first of all, in 1944, long back, Fremont Rider from Wilson University, he was a librarian there, and sitting in his chair, he was thinking and he was talking that the Yale Library in 2040, which is yet to come, it will have approximately 200 million volumes because of information explosion. So in this statement, you cannot find big data, but we can think of that imagination or anticipation which was there in 1944. That means almost 100 years back, almost 100 years from the date for which this speculation was done, that these many volumes will be there because of what? Information explosion. And that is very, very right, because we are right now in the middle of information explosion. Then in 1980, a sociologist, Charles Tilly, he was the first person to use the term big data. What did he tell? None of the big questions has actually yielded to the burgeoning of big data people. And this was this Oxford English Discovery folks, they discovered this term. So big questions of the big data people. So what does it mean? That means that the big data is coming somewhere from the data which was collected till then. So that is, it is something beyond the data which was till then available. In 1990, Peter Denning, he said, it is impossible to build machines that can recognize or predict patterns in data without understanding the meaning of data patterns. So now, by 1990, what happened? People started talking of building the machines which can recognize something beyond the normal data, something beyond the patterns that were in the data. So building machines to cater those kind of data, that means talking of the storage systems or the complex systems which can handle the data which is higher and bigger. Michael Cox and David Ellsworth in 1997, they used a big data for the first time in print. So there, the big data came into print in an article in ACM Digital Library. So here we can say that we read the big data first in 1997. Then many people were there who were talking of this 1998 big data and the next wave of infrastructure. So there was many things which started coming about the big data. 3D data management, controlling data volume, velocity, and variety. This was a major breakthrough when 2001, Don Lene, he was from Gartner, he said 3-dimensional data management. So what is that? He talked of 3-dimensional data management, where he was talking of the data volume, the data velocity, and the data variety. So these were the basic 3 V's which came up with the big data. Then 2005, there was an article which was published on what is Web 2.0, and then it started the race for big data. Then Yahoo then came up the need, since the big data we had talked of a lot, people had talked of building machines. So now in 2005, Yahoo created Hadoop to build on the top of Google's MapReduce. So Google already had MapReduce. Yahoo came up with Hadoop. And this is, I have got from a policy paper which has been published by NAS in 2021. Anybody can read it. It is a very, very good policy paper which talks of big data in agriculture. So it has a very comprehensive information about big data and how it can be used in agriculture. So whenever a new thing comes, whenever we encounter a new technology, a new term, a new tool, there are challenges which come up with it. So here, there are challenges, big challenges, because big data is being talked of a lot, but still it is in a nascent stage of getting involved. So the challenges are like, if you have more data, you need more storage spaces. And since more storage space, that means we have to spend more money, because the storage is costly, we all know. And RDBMS server, they need very costly storage. So, and we are not talking of RDBMS, because RDBMS is not going to handle our big data. I will talk of big data in detail. Then data is coming very fast. To speed up the data processing, it needs to be handled so that it is capable of handling and taking care of various data structure. For example, how do we put JSON data format in standard RDBMS? I have a JSON, but I have to use it in RDBMS. How do I have to transfer it, and how do I have to transform it? Then somebody will come up, okay, XML format is there. So we also have XML format from other sources. How I can use it in a big data environment? Then other systems which have different kinds of formats, they will come up and ask our big data platform that where you can put us and where you can use us. Then agile business requirement is there. So ETL processes cannot handle all this big data. It is not only extraction, loading, transaction and loading. So it is beyond that. So we have to understand that big data, we cannot directly take it to the RDBMS. We cannot talk of ETL tools and getting the results that we are looking forward to from big data. We have moved ahead. It has evolved. We have new things in place which are setting up a big data environment or an ecosystem. We all know the storage costs have increased. So, but compared to others, Hadoop has a lower cost from the standard RDBMS. First thing, standard RDBMS have very restrictive and limited limitations for storing the data. And then they come up with a very high price. There are open source RDBMS, but people hardly use them. Whereas Hadoop has very low pricing as per the storage cost. And that is why it has evolved and it has won over the other tools which were coming up to handle big data. It provides highly scalable storage and process with fraction of the earlier cost. So, and then Hadoop is an entire framework. It is not a software. It is not a database. It is not a particular tool. It is an entire framework which talks in terms of big data, which talks in the language of big data, and it handles it from end to end. I will not emphasize more on Hadoop here because I am here to introduce the big data analytics. So, but this is, we cannot complete a lecture on big data without the without mentioning Hadoop. So we can just, it is just a picture that shows that how Hadoop and Netezza from IBM or Exadata from Oracle or Teradata from Extreme Data Appliances have the costing of storage. So we can see that it is much, much lower with compared to the other IBM, Oracle and Teradata. So, and then storage, and when we talk of storage and storage, we have to talk of the computation also. We cannot go separately that, okay, I have my data here and now I will go somewhere else and compute it. No, I cannot do it. The older way was that the computation was getting done at the same place. You have then RDBMS, then a network, the data storage SAN or NAS was there, and then they were talking to each other and doing it. Now, but they were differently placed. RDBMS and your data storage. But now what we have to do is, it has moved ahead. Hadoop, what does it do? It has the storage here. It has the computation here. It has the analytical tools also. It has something, some provision for having analytical tools also on the same framework. So the commodity unreliable services, the hybrid open source software, Hadoop is an open source software. It is called a software, but it is an entire framework. So that is, it does not have any bottlenecks that, oh, what should I do? Because I can store the data, but I cannot have a computation here. I will have to go somewhere else for computation. No, it doesn't have that. So, and it has the capacity to ingest any kind of data. Different kinds of data are coming from different sources, and Hadoop has the strength to handle it. It can also handle the agile data access, wherein the old system network was a bottleneck that if your network connectivity is not proper, you will not be able to fetch the data from the data storage and get it analyzed. Then only it was handling only the relational data because we had RDBMS. And since it was RDBMS, it was difficult to add new fields and data types. Data types were difficult, more difficult. New fields still we can add in our tables in the RDBMS, but for data types, it was difficult because there is a set of established data types which RDBMS can handle, wherein Hadoop has no limitation of such kinds. So the source for this is Cloudera, which Cloudera has a very good big data platform, which can be, which is open source and it can be established if somebody wants. Now, so how did it all came and started? It is a small picture that I want to show, that we started with data, and then data were getting started in databases, storage in databases. Earlier it was database management system, only DBMS, and then it came to RDBMS, relational database management system. Moving ahead, there were transactional systems in which data was moving. Then very, very large databases started coming up because data was being generated continuously. It was getting stored continuously. But what was happening? The data explosion had started. It was going beyond RDBMS. So very, very large databases, when they started, the data got accumulated and they become very large databases. People started thinking of something else, that where should they be stored? Then came the concept of data warehouse. When we talked of data warehouse was talking in terms of non-relational database management system. So because there were two reasons. One, data was coming at a very high speed, and then data was coming in different types, different formats. So if we were talking of the RDBMS, it was not possible for the RDBMS to handle new formats and new types of data. So data warehouse people started talking of, fine, we don't want RDBMS. We will put and store the data in a non-RDBMS format in different architectures. So there are different data warehouse architectures and schemas in which the data is stored. So they talked of multidimensional cubes, they talked of different schemas, stars and snowflakes. So they started storing data in that format. Now, data warehouse, for a long time, data warehouse was there, and people had became quite satisfied. Okay, fine, our data is there. But in between, all these things came up: social media, IoTs, artificial intelligence, and different kinds of devices which started generating the data, and data got generated in a different format, different way, and in a different speed. So people started talking of big data. Now, big data also, now still we are in the ages of talking of big data, analyzing it, storing it, but moving beyond that, data lake houses have been started getting evolved and getting the recognition, because once we are moving ahead of big data, the kind of data, the data lakes or data lake houses are being talked of. And what is there? So what we can do in big data, now we have already talked of databases, RDBMS, and why we are moving to big data. Because there are three kinds of data that we handle in big data. The major point of division or differentiation of big data from data is that the data types in big data are differentiated or classified into three categories. First is structured data. So structured data, when we talk of, it is the RDBMS data or the relational database management, the data which is in relational data. So when we talk of big data is encompassing all kinds of data. It is also taking the relational data. Then the semi-structured data. Semi-structured means there is a structure of the database, but not restricted to the relational data. And this data is the XML data. We all know about it. Then going beyond this, these are structured and semi-structured, but there are data which do not lie in any of these categories. They are unstructured data. For example, the words, the PDF, the text, media logs, Twitter, video, audio, and many, many kinds of data. So this is a diagram which shows that how these differ. Structured data looks very, very disciplined. It's a very disciplined kind of data which follows a certain rules regulation. It is related to each other through the techniques, the technology, and then the querying and the analysis is easier in that. It's very, very easy in that. It does not take care of any other different kinds of data, which is not disciplined. Now, when we move to semi-structured data, right, it is like a child which is disciplined, but at the same time, it is notorious also. So semi-structured data is an XML data which has certain rules, regulations, but it is not entirely disciplined or limited to a particular rules and regulations. Now comes the unstructured data. It is everywhere. Everything is coming here, there, but it is having an attitude that you have to take care of me. You have to find ways to take care of me. You have to find ways to analyze me. You have to find ways to store me. I am not useless. I may be unstructured, but I am not useless. So this is what unstructured data tells. So when we go beyond this, I had talked of
I think there is trouble from the speaker's side. So she is getting connected. Let us wait for a while. Yeah, it has come again. Ma'am, unmute from your side.
So earlier we were, I'm really very sorry for this technical glitch. I don't know how it happened. I'm really sorry. We were talking of the 3 V's which made data to be called as big data. It was a larger data sets. That means they were very large, very huge, very voluminous. So we called it the large volume, which got added to the normal data sets. Then the data was diversified, that it included the structured, semi-structured, unstructured. We have just talked of that what kind of structured, unstructured and semi-structured data sets are. So they started coming up in the various varieties. Now they were arriving very fast. Every second, every minute, the data was getting generated and coming. So this speed was something of concern. And this made the third important V when we started calling a data to be a big data. Now, what happened, what these varieties, and we talked of big data, that we call of volume, it started from kilobytes to megabytes to gigabyte, terabyte, petabyte, and we don't know how and for how long it is going on to be. Then variety, we have already talked of that text, click, web logs, sensor data, all kind of data is there. Velocity, earlier it was yearly data, 6 monthly data, monthly data, quarterly data, but now it is at every second, and every second means we talk of real-time data. At this point of time, you are live streaming this webinar. That means this live streaming is creating a huge amount of data. Then slowly, when people started working on it, they realized that they are not the only 3 V's which are of importance. They started thinking of more things. That fine, I have a large volume of data, which is of various varieties and coming at a very high speed to me. But now what I will do with this? Is it worth using? Is it useful for me? Does it contain any value, or is it just useless? So when people started talking of it, they started talking of the value of data. That means having access to your big data is all well, that I can access this, but that's only useful if we can turn it into a value. If I'm using that and this is giving me some value, this is giving me some value in any proposition, any time, then it is of importance to me, and then it is worth storing and worth spending a lot of money on. And then there was one more thing that people talked of. That was veracity. What is veracity? We talk of that you have a data which is just got generated and I stored it. But what about its quality? Is it going to give me the right analysis? Is it going to give me the right kind of information? Or is it going to give me something which is misleading? Right? So what I am doing is, I am talking of the 5th V, which is veracity. And this is the level of quality, the accuracy. The people who are coming, I think all of us know the importance of the quality of data, whether we are handling it or not, whether we are analyzing it or not. But the right quality, the right amount of data has to be in the right quality. Quality, then accuracy. What if I am getting a data which is 5 years back? I am not going to use it for any purpose. It is not useful for me. So what I am doing is, this is the accuracy is important, and then importance comes to the uncertainty of data, whether it is uncertain, that I don't know whether it is right or wrong. Can I take a decision based on this? No, I don't know. So all these things were very important. They were considered to be very important by the people who were handling the data. We started talking of big data. So these 2 things were added to the earlier 3 V's. And then we started talking of the 5 characteristics, the 5 V's of big data, which is the major characteristics: volume, velocity, variety, value, and veracity. Now, so all those things, they represent data creation. When we talk of all these 5 V's: acquisition, processing, generating the values with certain uncertainty. So this is why this is a table which gives a very holistic view of how we handle these 5 V's. When we talk of variety, we are creating data. It is in the bottom of the pyramid that we have data, creating data data is got generated. It is already stored. Now it is in different varieties: mobile, geolocation, email, machine and sensors, relationship, social influence, social media, text messages, anything. So it is just your data, creating the data. Once you have created that data, we move ahead. We talk of data acquisition. Data acquisition, because how this data is coming, how fast is this coming, and at what intervals it is coming, how I can use. If we remember, all the statisticians, we can remember that we still talk of time series data, how important it is. And time series data, the time interval is important with respect to the various application areas when we talk of. So it is similar that when we talk of rainfall data, we want it on daily basis. When we talk of some other meteorological data, we want it on daily basis. Those are time series data. They are very, very important. And similar here, the data, when we talk of data acquisition, data is acquired from various places in various forms. So creating a very huge volume, and this volume has to be stored somewhere. We were storing it on our normal servers or machines or everything, but it has gone beyond that. Now cloud is there, Hadoop is there to handle it. Then various things are there which we were talking of here. Like for example, there is one thing which is non-relational data warehouses. So I had talked of that data warehouses, they don't take the RDBMS. They store the data in non-relational format. Velocity and veracity, it is information processing, because this gives the chance to forecast, to predict, to estimate. So all those things, when we talk of, we need the data at certain intervals. It can be higher or lower. The point that we are getting the data in real time gives us an edge over the data which was stored way back in years. So what is coming up is, right now what has happened. It will depend on what was happening 2 minutes back. Now what has happened right now will decide the next move. So this is happening. And when we are talking of this business intelligence or everything, then forecasting, modeling, data exploration, contextualization of data, all these are things. These things are not jargons. We are not going to get scared of it. We don't have to, because they are just the evolved version of what we were doing earlier. So we have also to evolve, take care of this new kind of data with the new technologies in place. And then comes the business processing, because once you have done all this, what now? I have analyzed, now I have to analyze my data and then find value from it. That means earlier we used to say, what is the inference which is drawn from your analysis? Because statistical analysis, when we do, it gives us result. It does not give us the inference. So there's a difference. Statistical analysis, any analysis gives us the results. And from those results, we have to infer. Inferences come from the results. And it is based on the person who is doing the analysis, and it is also based on the requirement and for what purpose the analysis was done. So what inference I am drawing from my analytical results is the value. Is the value the data is giving me. So when we talk of value in terms of big data, it is the business processing. So what is this giving us? That I have this data, I've got it analyzed after all those steps, and now it is giving me a value, that it is giving me a location-based service. I can decide upon it. This is the decision I have taken, and this has increased my worth or in terms of professional excellence or skill management or skill excellence or even the monetary gain or in terms of decision-taking power. All these things, they are what the value is going to given by the big data. So now I have talked of big data, what big data is, and now I will be talking of big data analytics. So big data analytics, there are many tools. There are few which I have talked of here. I will be talking of more in the next slides. So For data storage and processing, we have this, which is Hive. Then for data analysis, we have Pig. Data warehousing, we have this. Then NoSQL databases are also there. NoSQL databases are there. Because earlier it was sequential database, sequential SQLs we used to use. Then real-time processing. For real-time processing also we have. And then messaging system. So this is just a normal diagram that I've shown, but it is not all, it is not comprehensive, it is just limited to few of the tools. So why do we do analytics? We have never questioned ourselves with this question, that why do we do it? We do it because it is in our blood. We do it every day. We do it everywhere. It is not only the statistician who do the analysis or analytics. We do it every day, everywhere, everyone is doing it. So do we realize that you do analytics every day? For example, I have to reach to this office faster, or I have to join this Zoom meeting at the right time. Looking at the sky today, I think it will be raining. It will rain. Every day we look at the sky, oh, clouds are there, maybe that it rains, or the monsoons have come. No, today there is no sign of clouds. So all these kinds of things we talk every day. For example, based on my midterm and assignment score, I need to get at least 80 in my final exam to pass this course. So this is the estimation, the things that we are doing. I stalked her social media. I think she's single because most of her posts only about food. So this is an analysis that some person has done. This is what we do every day. Everyone is doing. So analytics is in our blood. So it is not that only because we are statisticians or we are computer science people or data science people, we have to do it. Now, what all kind of data we are talking of? We all know that data comes in different shapes and sizes, different forms. So qualitative data, types of data, qualitative, quantitative, all of you who are from statistics all know that what kind of data are there. Nominal and ordinal, and then discrete and continuous. These were the data we used to understand earlier. But now data has come in different forms. And since data has come in different forms, we have to move ahead to the analysis. Now, I have a very, very small submission to say here that any data when we analyze, whether it is statistical analysis we're doing or we are handling big data analytics, there are major 4 things which are carried out. Either we do all of them in one go, or we do 1 or the 2 or 3 in any combination. They are, first of all, diagnostic analytics, prescriptive analytics, predictive, and then descriptive. So how do they differ? First of all, when we diagnose, it is like going to a doctor. It's a very, very small example that I would like to give. It is like going to a doctor and telling that this is this, I'm having headache, I'm having this. Now, what he will do, he will ask more questions. What is happening? Do you get nausea? Do you get this? Did you not sleep properly? Did you not eat properly? Many questions. So it is like asking the question, what is happening to you? And after these preliminary stage of processing or asking questions, doctor comes to a conclusion and he writes that you have X problem. For example, you have indigestion because you could not sleep properly, you did not eat proper food, you ate outside or something. So it is a diagnostic. So data mining methods, they organize the data, they help uncover patterns. So what they are doing is they are diagnostic. Next step, what comes? Prescriptive analytics. So what we are doing is, next question is that now what is to be prescribed? Kya karna hai? Doctor will tell you have to do this. You don't have to do this. So all these things are given. You have a prescription in hand. Now the third question comes that what is likely to happen if you don't do this or if you do this? If you have 3 days antibiotic course, you will be fine. If you don't, you take proper rest and you take proper sleep, you eat homemade food, you don't eat this or you don't, then you will be fine. Or if you don't do this, this is likely to be happen. The last question is descriptive, that what should be done in the bigger scenario, that if I have done all these, you have taken all these things, but if at all it doesn't, what is there to be done? So this is something like going to a doctor and then handling your data. So you are a data doctor. I would not call you a data scientist. You are a data doctor, and what you are doing is you are giving an end-to-end treatment to your data, right from prescriptive analytics to diagnostic, then descriptive, then predictive, and everything. And then your data is fit and fine, giving you value, having a nice time. So this is how I talk about the types of analytics. More diagrammatically, this is what happens. First of all, it started with what has happened, describe, just describe it. Ye hua, wo hua, aisa, vaisa, whatever you want to tell. Then it comes to diagnosis. Okay, fine. You suffered all this, you are experiencing all things. So I can understand, because I am asking 100 questions more, and then I will diagnose. Then I will predict that this will happen if you don't do it, and this will happen if you do it. So this is what, because diagnosis has been done, you are having indigestion. Now prediction is that if you will not take proper rest or this or that, then you will not, if you not eat homemade food, then you will be in trouble. You may experience more problems. And then to avoid these things, you have prescription in your hand. So the difficulty levels increases as we go from one step to another, from analytical perspective. Description is the easiest, because here it is only the information that you have at one point, one place, and you are what is doing, what happened. So you have all the description. It is the easiest. Then why did it happen? This is something where you have to dig into the data. Okay, fine. This is what we have. Now, why did it happen? So you have to ask questions to your data. Then again, what will happen? Now you have the scenario that why did it happen? But now you have to foresee. You have to foresee that what will happen if this or if that. Then once you already done with that this may happen, you have to come up with a solution. That fine, I have to stop this, or I have to encourage this, so I have to do this. So the difficulty levels increases from information to the optimization of the data analysis. So it is a hindsight, it is insight when you are doing diagnostics and predictive, and this is the foresight. So descriptive analysis is the first thing that tells us that why did it happen? It is this data visualization. This is the descriptive analysis. This is picture is showing the descriptive analysis, that what it is about, a part of data, and what all you can see from this is the data visualization. So they are the core traditional BI. If we talk of business intelligence, then you have to visualize data, understand that what has happened, what is happening over the period of time, and how to go about it. Then diagnostics. It examines the data so that we can answer why did it happen? Kyun hua? Visualization tells me that this is all which is there, but why it happened? So the discovery of data through mining or more depth into the data. So the correlation and the data, what is coming from somewhere, what is the reason why it is happening, all these things are to be answered here. There's one example that one HR department, it is seeking to find the right candidate to fill a position. Now, and select and compare with other comparable positions to test performance. So what it will do is that it has a data which was given in the visualization. Now, the department will see that where does the particular person fit, who has to be picked up. Does it have these qualities? Does it have this experience? Does it have this qualifications? So it will be, they will be picked. Now predictive, what will happen? Predictive analysis is something like that, that what will happen? I have this data, but what will happen if I do it or not. Diagnostic examines the data, and this is about predictive. Revenue forecast, rain forecast, yield forecast. So all these things are predictive analytics. We call them that we are prediction of the yield as in another 5 years. What will be the food grain storage or food grain production of particular crops in this area? So this is what we are doing in predictive analytics. So forecasting, whether it is another prediction or forecasting, we all know this. So this is what there is nothing beyond these 4 things that big data is doing. What we are doing with our data, what we were doing with the data is similar to what we are doing with the big data, but in a bigger way, in a different setup, in a different framework, using different tools and techniques. And then prescriptive analytics, how can we make it happen? High prices and production recommendations and detecting fraud. So how we can do it? So this is the prescription. For example, this is something we encounter every day. You just go on Amazon, it will give you 100 things that you can, which are recommended for you. You go on Netflix, you watch one series or something, and then the next time you open your Netflix, it will tell you 10 more things similar to what you have watched. Or it will also tell people who watched this, they watched this also. So this is recommendation. And so this recommendation or prescription comes when you are done with all the first 3 things. Visualization, as I said, was the first thing, and it is very important. That is why I have put in this slide. These are few of the tools which are used for visualization. Tableau, Qlik, Infogram, all these things are used for visualization. So it is very important because it tells you what and how your data looks like. So in the big data, when we talk of, these are very, very important, because then only you can analyze your massive data information and take the decisions. So visualization is very important because it gives you the entire look at your data. And this is the first step for the diagnostics. Now, the basic rules for data visualization, we can skip this, but then I had just included this. Now, since we have talked of how and what kind of analysis we are doing, or what 4 things are important in the data analytics in big data, we must know that what is the life cycle of an analytics, what we are going to do with it, how it is going to move ahead, what are the steps to be taken. So first thing is, for any problem, any analysis, anything which we are going to do, we have to gather the information about the problem that is going to be solved. Or we call it problem identification or application area identification, whatever we call it. But it is gathering the information about what we intend to do with the data. And then defining the goal to solve the problem. That fine, I want to do this. I have to find out the fraud from this data set. So what is my goal? How I would find out? I will set in some parameters. I will go ahead and find out who are the people who are coming under those parameters, who are abiding by those parameters. Then defining the hypothesis. How it will happen. What is my hypothesis? If this is there, then only I will call that this person is a fraud or this is not. And then how important it is. How important it is, and analysis of the methodology is important. Now, we have understood that my problem is this. Till now, I have not talked or touched my data. In the starting, I'm not talking of and touching on my data. Now, I come to the point where I have to understand my data. Then what I have and what I want. Maybe I don't have all the data that needs to be addressing this problem which I have formulated. So what I will do is define the variables to support the hypothesis, because I have already done the defining the hypothesis task in the first step. I have my hypothesis in my place. So I have to define the variables which will help me support this hypothesis. If I do not have those variables in my data set, either I will define them or I will find them out from some other data set and put it in the data set that is going to be analyzed. Then cleaning and transforming the data, which is the most important part. At times, you don't have data which is right for analysis. So what we do is we want to clean it and pre-process it. So when we want to clean it, there are methods, there are processes, data pre-processing, we call it data pre-processing. There are many methods of cleaning the data, transforming the data. Now, cleaning only doesn't mean that you have to remove which are duplicates, or there may be missing data. There may be data which are outliers. So there can be many things. When we talk of transforming data, it is that maybe that for this purpose, you are using some method which needs your data to be in a certain format. So then we will transform our data. A simple example is when we talk of statistical analysis, what we try to do, we try to get our data in a normalized format. So if the data is not normalized, we transform it. We normalize the data. So it's a transformation. So similarly, many kinds of transformation are there. Then create longitudinal data, trend data. Longitudinal means put it in a tabular format. Ingesting additional data if needed. What I told you, that if you have variables which are already there existing, if they are not, then you may have to bring in more data points from some other sources to complete your data. That means ingesting the additional data also. So your systems should be so robust that it is not disallowing other sources to give you data and then use it for the analysis. Now your analytical data mart is ready. Your data which is to be analyzed is ready. We call it mart because things have come from here and there. Now data mining and modeling. Now we have to understand that we are not talking of statistical analysis here. There is no term which is telling that statistical analysis and modeling. It is telling data mining and modeling. So there is a limitation to statistical analysis, and then there is a limitation to data mining also. But we all should understand that data mining has its foundation in statistics. So no data mining can be carried out without the statistical foundations. So what is being done here? You have to find the variable which you have to target, which you have to predict, or which you have to regress, or which you have to find out the value for. Training, validating, testing, all those things have to be done. Analysis has to be done, correlation hai, variable, whatever you are doing the right data mining algorithms are being run on that. So by validation, what we are doing in the end, when you have developed a model, when we develop a model, what we do? We test it and validate it. So finding the right model is only complete when you validate the model. And it is by measuring the accuracy, sensitivity, and model length. So these are the evaluation measures for a model, for any model in general. And when we talk of different tasks or different things which we are carrying out, or different analysis, then the evaluation measures change. They are different also. But these three are common to all kinds of data analysis, because even if you are doing classification, you want the accuracy. You are doing clustering, you want the accuracy. You are doing association rule, you want the accuracy. So all those things are common to all of them. And in addition, there may be more evaluation measures for different tasks of data mining. Model interpretation is very important, because you have developed your model, you have tested it, validated it. Now what? What was it? If I come to you, what was it? What did you do? So you have to answer me. Describe the importance of each variable. Why this X is important? Why did you take this Z? Why did you leave this C? What do you mean by B? So all these things are important. Then take a holistic view of overall model by creating a decision tree, for example, that this is what I done, then this, then this, then this. So, for example, this is an organizational tree or decision tree you have made. Now, based on the interpretation, we will take decision. Then once this is done, now your model is ready to go into the market. Operationalization. That means taking your model to the market, to the stakeholders, to the users, and asking them, go and use it. I have validated it. I have tested it. And these are the meanings of my model. If you want to ask, I can tell you, what does X mean, what and why I have taken this parameter, why have I left this, what are my constraints, what are the different values which I am looking forward to. All these things are important. So when you go and you start using the model, it is a model operationalization. And then once it is done, what next? Keep a track of what is happening. We have to keep a vigil that how my model is performing on different data. Is it scalable? Then your model understanding or model evaluation also comes into picture. That create monitoring process for model evaluation. Evaluate the model based on real world results, because a model may work very well with a disciplined data which is with me, but once it is being used by the actual users, it may have different kind of behavior. So we have to understand that this model, when goes to a real world problem, when it is addressing a real world problem, how is it performing? And what are the things that I have to go back and do with the model so that it performs very well with the real world? Because in real world, you have dynamic data which is coming up, which is not in a particular format that we were talking of. So our model has to be very robust. It has to be scalable. It has to be very, very robust to take care of any kind of data. So monitor and evaluate the business impact. That how does it going to impact the reason for which I developed this. We all know that analysis and modeling is an iterative process. As I said, that when you evaluate, I may come up with 3 things. That fine, if I do it, if I fine tune this model, it will work well. So again, I will go to modeling. And then again, I will come to analysis. So data model will become obsolete and need to evolve to accommodate changes in the behavior. This I have already told. So this is the analysis life cycle, which goes on in an iterative manner. So if I talk of this thing in brief, that how do you build the methodology for analytics? It is analysis domain, that where are you going to do this analysis and what is the domain? Is it for a particular area? It is only for a particular discipline, or it is for particular people, or it is only for the students or only for the faculty, for example. Then type of analysis. Do we need only descriptive? Can all the 4? Maybe I am not interested. As I said, either I can have all the 4 or I can just stop after having a description. I just want my data to be visualized. I just want to know where my data is and how does it look. So my analysis will stop there. Descriptive analysis done. I don't want to go for predictive. I don't want to go to diagnostic. But it entirely depends upon the need and the requirement for which we are gathering all those data. Supervised or unsupervised? We all know that either we are going for analysis which is supervised or unsupervised. We all know, I will just quickly tell you that it is, when we talk of this, we are talking of data mining as analytics. So data mining has, or any analysis is of 2 types, supervised and unsupervised. Supervised has a list of tasks and unsupervised has another list of tasks. Supervised is classification, unsupervised is clustering. Supervised is association rule, and doing this without the labels is your unsupervised. So do we want to do this, or we want to go ahead only with the descriptive? Define analysis time window. When do you want this? what time window of data we need for behavior observation. It is something like the time series data when we talk of that. I want 50 years data to predict this. I want 20 years data, or I want a week's data. So this time window is very, very important if we are talking of prediction. So what is the prediction time window? Do I have to predict it for another 2 months or 1 month or 1 year or 6 months? So this is also important. Is there any seasonal event on that window? So this may sound different, but it means the same thing what we do with the time series data. Seasonal changes, seasonal behavior of the data in the time series data is very important, which is handled. Now, what are the analytical tools? So, as we have been talking of analysis, we have talking of big data. What are the tools? There are n number of tools, both proprietary, open source, semi-proprietary, license-based, all kind of things are there in the market. Few of them are here, which I have just shown here. SAS, Apache Spark, Qlik, Talend, Sysens, R, as we have talked of it, Excel, Tableau, Power BI, Python. Python is a scripting language which has taken up very well everywhere, at least for big data analysis or artificial intelligence analysis when we do it with the deep learning or ANN or anything. So Python has taken up very, very well. It is very dynamic because the coding can be done. So I don't need to tell you what data analytics tools are, but these are the names of the tools that I tell you. So I have introduced 3-4 slides telling about the data, which is the analytical tools that we use for big data. First is the MapReduce, which is very important in a Hadoop framework. And what does it do? It processes the data in parallel ways. MapReduce means it reduces your data to be channelized and used in a different method in parallel form. So parallel data processes data in parallel way using distributed algorithm on a cluster. So for understanding the big data analytics, we have to understand what kind of architecture is used for big data to analyze the data sets or to process the data. It is a distributed framework or distributed environment where big data works. Distributed means they have many nodes, many systems which are connected to each other. And then the data moves in a distributed format. This performs filtering and sorting data locally on the systems and reduce the procedure, performs a summary operation. For example, count or sum. So since this is not a class for Hadoop, so this is not a webinar for Hadoop. So I have just introduced that MapReduce is an approach for parallel way of distributed algorithm using the distributed algorithm. Then Hadoop versus unstructured data. Why we are talking of Hadoop? Hadoop has distributed file system, as I told you. Big data comes in, is being analyzed in a distributed file system. So Hadoop has it, and what it does is, it is just a file system. So what we need to do is just pick up a file and drop it there. We are not talking of database management system. We are not talking of DBMS. We are not talking of RDBMS, that your data is in that RDBMS, you have to pull it. No, it is just a file system. Create a file, drop it here. And then you can see that this is a RDBMS approach where you load the data to the database table and then the user uses it for analysis or business intelligence or whatever. This is your source data. Now, what is done by Hadoop is it applies the schema to the data here. There are different schemas. If some other opportunity comes, we can talk on that in another webinar or another lecture. Then the metadata is only taken up from this schema. Data about data is metadata. So rather than uploading the entire data, it takes the metadata and then the user can use it. So this is the difference between Hadoop and the RDBMS approach. Then comes Hive. which is data warehouse software for HDFC. With this tool, what is done is the schema what we have just talked of can be written for Hadoop distributed file system. It enables to write in various forms for XML, for JSON, and even the compressed formats. And it supports SQL language. So this will convert the SQL into Java MapReduce code, because MapReduce, as we talked of, it will not run directly with SQL. It will have to be converted to Java MapReduce. These are certain things which are technical, so I would like to have it in some other time. Another thing is Spark, which is for large scale data processing. It is very, very fast. 100x faster than Hadoop MapReduce in memory and 10 times faster on the disk. So this is Apache Spark. This is the setup in which it works. So if you want to understand it, there are many tutorials. I have given it in the references also. If somebody wants, they can go on there and understand that. So Spark applications can be written in Java, Scala, Python, or R, anywhere. These are some other analytical tools. Microsoft Excel, SQL. It is just a language, but it digs into the data and bring it to your understanding. RapidMiner is one more thing, which is a data mining software. And it is a very good analyzer and analytical tool. And what it has is, the library can be created on our own. If we want that we have to create a library for RapidMiner, we can do it. And the best part is that it can get connected to Hadoop and do more complex analysis. So RapidMiner has a free version also, and it has a proprietary version also. The free version restricts you to certain amount of data which can be analyzed, and otherwise proprietary can be done, can be used for any amount of data. K9, it is another very, very powerful tool for predictive analysis. So it comes from the group of data miners, and it's a very old software, but very powerful. Till date, it is working. The best part is that these softwares, even if it is RapidMiner or K9 or any other, they have evolved over the period of time, and they have made them eligible to be connected to or interact with the Hadoop environment when Hadoop is handling the big data. So it is not that K9, earlier they were not using it, but now since big data has come up in a big way, and Hadoop is everywhere, people are using Hadoop. So all those have the capability and functionality to get connected to Hadoop and work on the complex analysis. Tableau is a very, very popular data visualization tool, which used to come up with the data warehouse softwares, but now it creates very powerful dashboards. Dashboards, we all know that whenever we go to one site, or we see certain numbers or certain pictures telling us everything about the data which is holds. So that's our dashboard. So dashboards are very important these days. People talk of that rather than going into the website or portal or any application. People want to have a one eye glance. At one site, I can understand, okay, these are the things which are available. So it is a very powerful interactive dashboard. ClickView, it is similar to Tableau. It is also for visualization. And in this, you can see that I have already written that which are freely available. RapidMiner is freely available. K9 is freely available. Tableau is also freely available with some limitations. And ClickView is also freely available. Now, analysis, as we have talked of a lot. Now, processing, how does it do? Big data is there, you analyze it, but it is still scattered. You can see this. This is totally scattered. Analysis, still it is scattered. But when you take the decision, it gets bound up. It comes at one point, at one place in a disciplined manner. So you input the data, stream processing engine is there where your all Hadoop framework works, your all tools work, and then you get the outputs. So this is the process modeling for model for the data analytics. You identify business problem. We have already talked of it. It is the same thing, that is the life cycle. Identify data resources, select the data. It can be from different resources also, something from somewhere, and then you have the data mart ready. Clean the data, transform it if needed, analyze that, and interpret, evaluate, and deploy the model. Since I had been asked to talk of the scope, so I have just taken this big slide for this, that what are the application framework for big data. Big data handling and processing comes up in this manner, that from machine to the human interactions. What happens? We can see here, this is proximity to end user and front end to the back end. How does it happen? This is a graph, 2D graph. Here, you call machine to machine, human to machine, and human to human. So when we talk of machine to machine and we call of backend and conception of new solution, we can see this. The flow analysis, energy consumption, we can have it as big data analysis. Moving ahead, we talk of machine to machine analysis, and it is the middle end, whereas we are talking of optimization of the existing solution. If you already have some solution, now you have more data with it, big data is there. What you can do? You can process it. Smart cities, default and failure detection, etc. We can hear many cities becoming smart cities. Smart city projects are going on in the country, in many cities. What they are doing? They already had everything. They already have the solutions. They already have the data, information, resources, everything. But what is being done is they have been put on in a very defined manner, in a smarter way, so that the things are more understandable and the things have got added to the value is going added to the things which are already existing. The last thing comes when we are talking of machine to machine, front end usage of the information. Now you have information which you have processed, and the information is here. In the smart cities, let us say, you have to monitor it. Control, home automation, security. This is what is being used. In, let us say, an example, a city has energy, it has security, it has police, it has everything, but it is scattered. It is not in a proper disciplined manner. Now, when smart cities came, through the machines to machines, what happened? The things have got more organized. When they have got more organized, that okay, police is also using some digitized things, and energy consumption is being taken care of the energy department by everybody, and they are recommending also how to utilize this energy efficiently, how to save energy. All those things are being done from machine to machine, and it's being told to the people. Now monitor it. For example, home automation or security, you can monitor it. You have security cameras which can be connected to the police headquarters, so that everything, or if somewhere some notorious activities are going on, police can have an security things, CCTVs or other kind of automation security systems, and then they can utilize this. For example, in foreign countries, they are there. Even if at a traffic light something happens, it gets recorded in the headquarters of the traffic police or so. So these are the smarter things, but they are from machine to machine. Machine is working for the machine. Now the next step comes when we talk of human to machine. So these are the application frameworks. When we talk of human to machine, what happens? Behavioral analysis is important. For example, a person every day goes to this particular place. A person who is going to this place is having fever for 4 days. So all those kind of things are behavioral analysis, which is trying to give us more insights to create a new task or new problem, or identify a new problem. Then what do we do? But this is from human to machine. Machine is only acquiring, but there's a temperature sensor where everywhere you go nowadays, everywhere you will find it. So that is human to machine. Humans are trying to monitor the behavior through the machines. Now, next step comes When you have done this, you have data with that. What you will do with it? You will try to figure out how to improve this. If there is some problem in the behavior, let us say there's a person who had fever for last 3 days, and he's still coming. So what you will do is, you will try to sensitize him or her that you should not come, or you should wear a mask, or something like that. This happened a lot during COVID. We all have experienced this. And then wearable technologies, human to value, virtual or augmented reality. So if we all understand, what has happened is, in the due course of time, those virtual augmented reality has come. If you go to a mall, there are people who are having virtual reality softwares, and the kids go there and they experience it. So there are wearable technology, smart watches are there. So it is monitoring you, it is giving you the results, it is telling you how your heartbeat, your oxygen level, everything. Then and all of them are creating the big data. Then human to human, emerging needs detection via text mining, then targeting, marketing risk, fraud, social networking, all these are human to human. Ek tweet hua, somebody else has retweeted, somebody else has retweeted. So these are the things which are getting generated through the big data. So how we handle it and process it. There is a huge framework, and there is a lot of things that big data can do it in agriculture. I have done here for a limited things, but this can go beyond it. In crops, crop production, biotic abiotic stress, understanding or study of abiotic and biotic stress, taking care of the plant protection through the data which is generated, insect pest disease, it can be identification, diagnosis, and treatment. All these 3 things can be done using big data analysis. For weeds, for crop yield monitoring, crop yield estimation, crop yield prediction, for everything. When we come to climate, because these 3 things are integral for agriculture environment, crops, climate, and soil. We all know that. So for climate, I have defined humidity, rainfall, wind speed, temperature, how to monitor them, how to find them, how to forecast or predict them for better cropping. Soil, for soil analysis, huge data set are there for soil with us. It is through the soil health cards also, or different portals, or different, even the NBSSLUP has huge data sets for soil. So what all we can do is physical condition understanding or study, soil texture, structure, moisture, nutrients, and more. So these are the things which can be dealt through the big data framework and analysis in agriculture. And for resources which are available and managing them, how big data can be used for water availability, topography, soil fertility, then organic matter, that how much organic matter is there and what is to be added, what is not to be added, how can we improve it, how can we take care of the soil to give us more yield. So NPK levels, moisture content, micronutrients, and more. So all those things can be taken care of with big data, because we all know, I have written it there, that complex system of agriculture can be modeled as follows. Ability to harvest is equal to the function of ABCD, where A is agriculture, B is biology, C is compute, and D is data. So this is a very important thing that I would like to convey, that when we talk of agriculture, we have to take into consideration very seriously these 4 things. It is agriculture, biology, computation, and data. So data has a very important part to play when we talk of our sustainable, robust, resilient agriculture system in our country. Do I have the time?
Yes, ma'am, you can proceed, ma'am.
Okay. So now what I will do is, I will just, I had this slide. This is more technical, but I just wanted to show it there so that if somebody is interested, we can have a discussion later on also, that this is something which shows the big data software stack. What all kind of big data softwares are available and how do they sit on each other. So for data analytics libraries, we have Mahout, ML in the Hadoop environment, ML-based, Complan, and then statistics, bioinformatics, then R is there, bioconductor is there. For imagery and ImageJ is there. Linear algebra, Scala, PET. So there are n number of softwares which are available, and they keep on coming. New softwares keep on coming. So this is all Apache. And then there are cloud, there are certain things which are available on cloud. Now, when we talk of big data, there is a governance architecture also. How do we manage the data? We have talked of what big data is, why it came into existence, why we needed different kind of storage, and then analytics, how we go about it. Then after all this, you have to govern that. You have to take care of that. You have to manage that. So the management and governance comes, this is a cloud infrastructure. Then these are the artificial intelligence and machine learning modeling and mining informatics in big data. These are the things which are bringing up the data, IoTs and remote sensing, scenario building, benchmarking, and all these things. Then you have all these informatics where you can use any analytics using AI or ML. What is it giving is, it is, when we talk of management and governance, it is web services, internet portals, phone and SMS. Through in this, what we can do is, to the IT industry, web services, R&D institutes, financial institutes, consumers, agri-business industry, government institutions, and above all the farmers. We can use this big data, getting analyzed, taking the information or the inference drawn from the analytics, adding value to them, and then giving it to the people so that it can be managed. Now, what happens here is, internet portal and all these things can be given to for policy making, forecasting and forewarning, short-term measures, risk coverage, public and private partnership, enhanced productivity, profit farmers and entrepreneurs and consumers, and efficient and transparent system. So this is how the management and governance structure look for a big data environment. And this is very important. Everything can be kept on a cloud infrastructure, because the need of the hour is, you can have, everybody cannot have big data centers to have very, very high configuration of servers and then keep your big data there. We have to have cloud infrastructure on which we can store our data. The application areas are wide: banking and securities, communication, media and entertainment, healthcare, manufacturing and natural resources, transportation, education, retail and wholesome, and insurance. Now, what we can see from all these 8, they are not limited to 8, there can be more, that all these sectors have huge data which is getting generated. So we can understand that all of them already have big data. They already have big data, they are working on it, and they are coming up with very good scenario for policy making, decision making, and good and better services in all the domains to the people and the users or the stakeholders. If we talk of healthcare, we know that a huge amount of data is there, and healthcare is getting better and better every day. So it is not only the exercise that is for 1 day or 2 days. It has been for years. People have gathered data, analyzed them, have come to a conclusion for better prescriptions, better medicines, better facilities for healthcare. So all these things are coming up. And what does it do? It improves the customer service, as I said, better services to the users, contains better operational efficiency. Operational efficiency, when you have a decision in place which has been taken on a proper kind of data after analysis, you are in a better way to perform in the market, to operationalize the things. Better decision making, and it quickly identifies the risks of the products and services. And these are not only for these industries. Agriculture industry has huge potential for taking the big data with it alongside and getting the best out of best. Examples are forecasting, classification, recommendation, fraud detection, optimization, abnormal behavior. So abnormal behavior is not only restricted to the humans. It is abnormal behavior means an outlier. If we have an outlier in our data, that is abnormal behavior of our data. That particular point is not behaving in a proper manner. So that has also to be identified. So I will not go into the detail. Do I have time? How much time do I have? How much time do I have?
10 more minutes, ma'am.
Okay, so I will straight away go to a case study that I have used. Before that, I would like to show this application in agriculture. Weather prediction. These are important because we all come from this agriculture domain and we all have to work for it and do the best that we can do with the kind of things that we have, the resources which we have. You can see that here are sprinklers, and there can be, this is a sensor which is taking the data, collecting the data, and it is being stored here and captured here through the mobile device. So all those things, you can see that there are a lot of things which are happening in agriculture. Weather prediction, because weather prediction, you know that the kind of data that we gather is the time series data over the period of time of years. And so now every day was coming, but people have started talking of first 4 hours, second 4 hours. And if you go to AccuWeather or other weather prediction softwares or websites, we can see that at this point of time, this will be the temperature. At this point, this will be the... So where all this is coming from? It is not for one day they predict. They predict for the different hours of the day also. It is coming from the data which is being generated every moment. People have weather stations, they are giving that, and the weather stations are generating data on hourly basis also. The more data you have, the better analysis it will give you. Fertilizers recommendations. Disease detection and pest management. AI has been doing a great work in this. And this is because huge amount of data is being collected. I will just give you an example that we are running a project under NAHEP, and in which we have a component for identification of disease and pest using the images. Right. So right now we have more than 2.5 lakh images with us, which is coming across the country, coming from across the country. Sometime we can also talk about that. Some other time we can, but this is a real situation that I'm telling you. It is a huge big data which is being created here. ANN, artificial intelligence models are being built. They are running, but once it is complete, if we have the complete thing, we have to migrate it to the big data environment and then analyzing it into the framework that we have.
Okay.
Right now, the models are in place. We are trying and testing the models, validating them on the test data. But once it is there, as I told you, it is more than 2.5 lakh images. And they have been collected over the period of 1 year. We already are in the process of having a mobile application for that. But it is still in the testing stage. Once it is there, once it is launched, it will be of immense usage. So these are certain things, small things will make big differences. Everyone has to pull up the socks and find out what is the cutting edge technology we can use with the limited resources that we have. If we do not have, ask somebody else that if you have, we will collaborate and we will work. Right. Adaptation to climate change. Automated irrigation systems are there. Yield prediction, risk management, weed detection. There are n number of applications in agriculture which we can take off. And these are related to the fields that we have talked of. Going beyond the field, when we talk of the human resources, that is also important for agriculture. So we can talk of the building a big good potential human resource capacity building, when we talk of where it will come from the data which we have collected. If we think that we have 1,000 students who have a knack for understanding ANN or AI, why can't we build a group of those people and start training them? So these kind of things, big data will help. It is big. When we talk of big data, it is not that it is something very complex, or only when you have something complex or complicated, then only it can be used. It can be used for very simple things. Very, very simple things. You order a dish from Zomato or Swiggy or whatever. Next time when you open your Zomato, it will tell you 10 things. How it is doing. They are no better. Those people are no better than the minds which we have in agriculture universities, or the students or the faculty who are doing research day and night. But the thing is, they have captured the pulse of the people. They will tell you, okay, you had Rasgulla, now you can have Rasmalai. It is similar to that. And you will surely go and buy the Rasmalai. So this is what this big data is doing. We have to find out how we can take it to the field, to the farmers. That if you did this, do this. This is recommended for you. If you will do this, you will have. And then create a conviction in those stakeholders, which are farmers, that yes, you can do it without any risk. Then only big data or analysis or any lecture or any webinar will be useful. I can talk about big data from the books, from the things for another 1 hour. But what after this? So I would request our students, our fellows, that find out small things from the big data. And those small things will make big differences. As I told you, that a small initiative we have taken, and we are doing it here in ISRI. So big data opportunities are immense, better informed decisions, hidden insights. As I told you, that you have to find out that this I can do. And we can start with very small steps. For example, a postgraduate student, they can take a very small application or small initiative and do it in 3 months when they are doing their degree. Not to go through the normal traditional things. Find out a way that this is what I have done. I will tell you, we had an intern for a month who had come here in ISRI, and he wanted to do something in AI because everybody is talking of AI. This is a real thing that I'm telling you. When he came here, he did not know anything about machine learning or AI. He was assigned to a person. He gave him 1 week to read about ML and AI. Don't do anything, just read. He read it, and then he was asked, he came to me and he was asked that there are 2 things. What would you like to do with this? The knowledge that you have gained in a week. One was image detection, image identification. The other was voice recognition. I don't know why he is not from agriculture. He is an engineering student, 2nd year, he came here. He said, I would like to go with voice recognition. And you will not believe, within 15 days, not even, he didn't even take 1 month. Within 15 days, he developed a system based on Python, which can recognize the voice. Even if Lavanya gives me 5 audio clips of her voice, he or this system will recognize. Once he did this, I was sitting, because I was mentor to him, but one of my junior colleagues were with me. We both started discussing, why can't we think it for our disease prediction for the animals, livestock? If an animal is in pain, he may have different audios. He may sound differently. Why can't we do it? So these are the small things which we have to learn. He did it on a small data set, but we have a big data. We have the capability, we have the resources. The entire framework is there. So the students who are here, kindly do something like this. Think out of the box. Immense opportunities are there. Resources are already there. You come up with a problem, resources will be there. We know that faculty will always be there to manage the resources for you. So, and then automating business processes always there. Challenges are always there in data quality. We will not talk about them too much. I would like to go to since I was about to talk for R also, I have not used any R hands-on because unless and until you have Hadoop framework system on your thing, you cannot use R Hadoop. So, but I have few slides which will tell you that why R is best suited for big data. Big data is having different things, but R not only as R, but when we interact, it get interconnected with Hadoop, it is very good. There are 4 or 5 reasons. We know what R is. First of all, for data analysis, it's very, very important, and R is excellent doing it. So, which includes a variety of techniques, extraction of important variables, test underlying assumptions, maximizing insights into data sets. And when this is done, R does a very good job. Second, data visualization. We just talked of Qlik, we just talked of Tableau, which are data visualization software, but they are different softwares. I have to take Tableau, then I have to take one analysis software. When you use R in Hadoop environment, it does data visualization for you. So it is one-stop shop. Data wrangling. What is data wrangling? It's art of getting your data into R in a useful form. And R does it itself. So that's a beauty, that you don't have to take your data, transform it somewhere else, bring it to the software. No. If data R wants the data in some other particular format, it will do it itself. So again, one-stop shop. Then comes R. As I told you that all of the softwares, most of the softwares, for example, RapidMiner or K9, they have evolved over the period of time and they have made them capable of interacting with Hadoop. And similarly, R has also done that. So R Hive stands for R and Hadoop Integrated Programming Environment. So we can understand that R is a very robust software, which when gets connected to Hadoop becomes stronger, more robust and more efficient. So it allows our user to create the MapReduce, which otherwise you cannot do. Otherwise you have to go to Hadoop framework, bring in some other thing and then use MapReduce. And it is entirely in our environment that MapReduce can be used. So using Hadoop tools in our environment is something that R Hive does. So the integration is a transformative change to MapReduce, as it allows an analyst to quickly specify the maps and reduces using the full power, that how much data is to be condensed, how much data is to be reduced to take into the analytical stage. Orc is, now we have talked of data, bringing the data, transforming the data, then reducing the data till now in 3-4 things. Now all of these things have come, but what about the data storage within Hadoop using R? So what it does is, Orc stands for Oracle R Connector for Hadoop. We all know Oracle is a database. Now Oracle has collaborated with R to create a connector for Hadoop. So it is a collection of R packages which provides predictive analytic techniques which are written in R or Java as Hadoop MapReduce jobs. So what R is doing is, it is doing everything in Hadoop, but taking the help of Oracle R Connector. So whatever is done, it takes to the Hadoop, and then the MapReduce things or other things are being done. So Hive tables are there, the local R environment, it takes care of the Oracle database tables. So if somebody doesn't want to take the other databases, Oracle is there, which has created Orc. Now comes the Hadoop, the ultimate thing, where we can have the entire Hadoop within an environment, R environment. So it is open source collection of 5 R packages, which I have mentioned below. And they allow the user to manage as well as analyze the data with Hadoop from an R environment. Now you can understand the beauty of this. In a big data environment, I have my Hadoop framework, but I want to analyze my data using R. If we have RStudio differently, I cannot do it. I need some interaction or connection between these two. And this is done by R Hadoop. So it takes the data from Hadoop, does the analysis in R environment, and then brings it back. So this is very, very important feature that R has developed. So the packages that R Hadoop majorly gives is, these are the packages, RSDF. We know that Hadoop distributed file system, we all know about it. So if R is getting integrated, everything is R. MR2 is MapReduce. RHbase is the Hadoop base for distributed databases. PLY RMR. This packages is for the data manipulation. So the popular packages are PlyR and Reshape2 on very large data sets stored on Hadoop. So as you start understanding Hadoop, you will come across all these things, and then we can have the decision that whether we want R Hadoop or not. Then R Avro. This is the Avro files are there, and they can read and write, because there's a distributed system where different systems are there in a cluster format. If we want to read a file from somewhere, there are different techniques. So R does this with Avro. So this package adds the ability to read and write Avro files from local and HDFS file system, and adds an Avro input format for RMR2, MapReduce2. So it will read and write and create an input format which can be taken to the R MapReduce. So this is what R is doing. So, but as initially also I told, there are challenges. There are challenges because R runs only on the data that can fit into the computer's memory. And when we talk of big data, we cannot even talk of restrictive memory. So what is happening with this? This is there, and we have to come up with this limitation. We have to remove this limitation. And then the biggest issue is when trying to use big data in R is in-memory data. It has to fit into the RAM of your system. It's not even 1:1 because you are actually doing something with the data. So the good thumb rule is that your machine needs 2 or 3x the RAM of the size of your data. It is not that if I have 10 MB of data and I have 10 MB of RAM, it will work. No. I have 10 MB of data and I have 3 MB or 4 MB of RAM, then only I will be able to handle that in a big data environment if it is in R. Another issue is that data transfer speeds are extremely slow relative to the time it takes to actually do data processing. But I'm very sure that since these things have already come up, R would definitely work towards it also. They are also evolving. They have come till this stage. So R is a very powerful software. It has come up with things which can interconnect them to Hadoop, taking everything from Hadoop and working in their own environment. So it is a very important task which they have taken. Now, what is happening is these challenges, these restrictions or limitations have to be overcome by R. Definitely they would come because this is the market where they have to work and they have to go ahead. And to overcome these challenges, there are few strategies which somebody can employ till this happens. Sample and model. Just downscale your data to a size that easily can be downloaded. For example, this is downsample your database. In database, pull the sample to the developed machine. So you don't take entire data to the machine, development machine. Downsample your data. It has advantages and it is disadvantages. Because advantages is speed up prototyping packages. Ye sab hoga. But disadvantages are, again, you are analyzing the sampling data. It has done the sampling. It may scale up or not. For this model, this model may scale up for the entire data or not. So that is always a disadvantage. So these are few things, but for the time being, this can be done. Chunk and pull. Just make a chunk of the data and pull the data to the development thing. And this is done with the kind of task that MapReduce does. This is how you can do it. Split the data into logical chunks, make small groups of your data, but they should be logically integrated. Pull these chunks individually so that they go in smaller format, smaller sizes, in smaller packets, and then analyze it. This again has advantages and disadvantages. But as I said, these are the three strategies which can be. Third is push compute to data. And the thing is, do compression operation in database. Within the database, compress your data. And only pull the data which is compressed, so that you take the entire data, at the same time, not bigger in the size, so that the analysis can be done. So this is what all we can do when we are talking of R being used in big data. So issues of the analytics are many. Need for synchronization across data sources. It is very important when we talk of analytics, whether it is big data or normal data. Capacity building and knowledge upgradation. As I already told you, why can't we have a pool of people getting trained into this? Okay, you are expert in Hadoop. We are not doing it right now, but we have to do it. We have to take care of that. Confusing variety of data technologies. It is there. I have some other information, you have some other information, everybody is confused. Is this good or is this bad? Getting meaningful insights in timely manner. Time window or time is very important. If you have missed the bus, you have missed the bus. Then uncertainty of data management landscape. Today, my data management principles are different. My data management and governance hierarchy is different. Tomorrow it changes. So these things definitely impact the data analytics and the values which are added to it. Storage and quality is always an issue. We have to keep ourselves upgrading in terms of our systems, servers, storage, everything, and keep on doing the quality check of the data. Security and privacy, immensely important for everyone, because data is something which is very close to the heart of the people who generate it, especially in research and academics. So getting part with the data is only possible when security and privacy is ensured. Data processing and infrastructure availability. Yes, this is an issue. Sitting in ISRI, I don't think that we have an issue, but yes, across the country, that is a very, very important issue, that the infrastructure availability. I don't have an infrastructure to store my data. I don't have an infrastructure to build up a big data and platform. So those have to be overcome within due time, within the resources we have. And if we do not have, let us come together, collaborate and have that facilities. Whosoever has the facility, just expend your hands and take it to the other people who don't have that resources. We have a data center in ISRI. We have a disaster recovery center at Anand for this data center. We all know that, and we are building on it. We are strengthening it every day. We are extending to it to all the agriculture university. I think you may be aware of that. All the universities, we have Krishi Make cloud infrastructure also, so that nobody is left behind in using the resources and coming up with new technologies. Best practices we can leave. Now, in the end, I would not thank, but I will quote certain things, because I have been very, very thankful for this lecture. Big data is not about the data. So we should not understand that when we talk of big data, it is only about data. It is about the entire ecosystem where your data is getting generated at speed, variety, veracity, value is to be added, analysis is to be done. So it is the entire ecosystem. And it is indeed a buzzword, but it is one that is frankly underhyped. Yes, we don't have to make it overhyped, but yes, right now it is underhyped. We have to take it to a platform where we all can use it. It is not limited to the people who have the resources or who have a different class to use this data. We all have the right to use this data for our benefits, for the country's benefit, for the domain's benefit, because we all are contributors to this big data. So it isn't about bits, it's about the talent. So as I told you that an intern came and he did this. So we have so much of talent out there in the agricultural sector and the universities. We have to come, think and do it. Data is a precious thing and will last longer than the systems themselves. We may be here tomorrow or not, but yes, these systems will be there. Hiding within those mounds of data is knowledge that could change the life of a patient or change the world. I think we all will agree to it. Big data but plus algorithms turn meaningless things and clicks into detailed and intimate personal information. For example, Amazon is telling me, okay, fine, you go and buy this lipstick or you go and buy this dress. So this is something is amazing. Nobody was there to tell us before that. Big data is at the foundation of all the mega trends that are happening today, from social to mobile to the cloud to come. And in the last, data is a new science. Big data holds the answers. Are you asking the right questions? This is where I would stop. And if there are any questions, most welcome. Thank you very much for a patient listening.
Thank you so much, ma'am. You made a big success for this webinar. But the thing is, from our side, we have to develop the concepts and we have to identify the applications where we can do.
Yes.
At least with the as you told, there's a little bit of initiative also, if I proceed, so that we can learn more.
Definitely, definitely. We have also created a small big data platform in our data center. It is in an initial state.
On which crop you are working now at ISRI? Image.
For the disease and pest, it was on maize.
Maize. Okay.
Yes.
In cotton, I think at TNAU, some other person, Dr. Kalpana.
Okay, maybe. So that is how we can just come together and make a bigger platform where everything is there.
Yes, ma'am. Okay, from the side of participants, is there any queries? It is time is running up. Anyhow, a couple of queries are allowed.
Sure, sure.
But Ramanamurthy, do you have any queries here?
No.
Okay, ma'am. By this, it is vast lecture, but I could not see any queries in chat box also. People are with us only, but we got clarified many queries out of your slides itself, ma'am. I have a list of queries with me. I prepared a list about 8 to 9 queries. From your slides itself, I could gather the information. Thank you very much for your very patience in preparing the TPDs. And I profoundly thankful and appreciate your energy levels since starting the session and ending the session.
Thank you very much. It is just because of the opportunity I've got.
No, ma'am, that shows your passion towards disseminating the knowledge and the love towards your subject and potentiality. I am thankful to you, ma'am. And on behalf of all the participants and my department also, I am profoundly thankful to you, ma'am. And I request now another faculty from our department, Dr. B. Ramanamurthy, propose a formal vote of thanks.
Madam, thank you, madam. So my name is Dr. B. Ramanamurthy, Assistant Professor, working as Assistant Professor, Department of Statistics and Computer Applications, madam. So respected today's speakers, sirs and madams, and dear participants, a very good evening to one and all. So on behalf of Department of Statistics and Computer Applications and Organizing Committee, I feel immense pleasure to take this opportunity to propose vote of thanks on this national webinar on scope of big data analytics in agriculture and allied sectors. I sincerely express my gratitude and hearty thanks to Dr. A. Vishnuvardhan Reddy Garu, Honorable Vice Chancellor, Acharya N. G. Ranga Agriculture University, for his continuous encouragement in conducting webinars for the benefits of faculty and students. I take this opportunity to express my deep regards and gratitude to Dr. A. Pratap Kumar Reddy Garu, Dean of Agriculture, Acharya N. G. Ranga Agriculture University, for his encouragement and provided an opportunity to organize this national webinar to the Department of Statistics and Computer Application, SV Agriculture College, Tirupati. So further, I would extend my gratitude and thanks to Dr. R.P. Vasanthi Madam, Associate Dean, SV Agriculture College, Tirupati, who is guiding force behind for organization of this webinar with her able guidance. Now, I would like to express my sincere thanks to Dr. V. Srinivasa Garu, Professor and University Head, and Honorable Member of Board of Management, Acharya N. G. Ranga Agriculture University, for his opening remarks on this topic and his encouragement and suggestions when and then it is required. Further, I would extend my gratitude and sincere thanks to Dr. Ansu Bardwaraj Garu, Principal Scientist, Division of Computer Applications, ICAR, IASRI, New Delhi, and also today's speaker for a couple of topics on scope of big analytics, big data analytics in agriculture and allied sectors in a simple manner and excellent manner. So I extremely thanks to organizing secretary, Dr. P. Lavanya Kumari Garu, Assistant Professor and Head and co-organized secretary, Dr. Sheikh Nafiz Umar, Assistant Professor, Department of Statistics and Computer Application, SV Agriculture College, Tirupati, who worked with a team spirit to conduct this webinar. My deep sense and appreciation and thanks to all participants for attending this webinar and made it successful event. And also my heartily thanks to our students, M. Uday Bhaskar and G. Harish and P. Minruhi and other students for their technical support, and also thanks to our non-teaching staff Rajendra and Nagaratnama for this department to conduct this national webinar from the beginning to till end. So once again, I heartily thankful to each and everyone to made a successful event. Thank you, madam. Thank you very much.
Thank you for your formal vote of thanks. Ma'am, at last, I can request you, please share your PPT with the...
Sure. I will share it with you, Dr. Lavanya.
Sure, ma'am. Our people will be benefited, ma'am. In future, also kindly extend your support and help for us.
Anytime, sure. It is always a learning process. I learn a lot from you and it is mutual only.
Thank you so much, ma'am.
Okay. Thank you. Thank you very much.
Thank you so much. Thank you, ma'am.